Hello, this is Dr. Mike. This is for my CIS 2642 pen testing class. This is a look at the topic of exploiting host vulnerabilities. At the time of this recording, this is from our Pen Test Plus study guide, chapter 10. And we'll take a quick look at the chapter and really more looking at summary of the chapter, and we'll talk about some of the concepts here. So, chapter itself is chapter 10. You can see we're talking about operating systems. Even though there are some concepts here that are sort of either coming through the application and or coming through other methods. So a straight operating system attack definitely is possible, and this is where we'll look at the slide deck and see how your reconnaissance is going to be a huge part of this. But some of the chapter talks about certain attacks that we sort of mentioned before in application vulnerabilities, especially chapter 8, social vulnerabilities, which would be, of course, passwords, social engineering, things like that. So you might need some of these other attack vectors to exploit the host itself. And we'll talk about that in a second. So I'll give you an example. In any case, this is from the chapter. Again, we'll go over the summary. Just make sure I cover everything at the end here. And we're looking at attacking the host. So can't say enough, when you do your scanning during reconnaissance, if you can get the host patch level, that's going to be very important. So, but it's going to be pretty hard. A straight host attack, it's going to be very difficult sometimes. You're really going to need to lean on any possible Metasploit framework attacks if they're available. But they are there, and they are patched. So that's the key. If the client or your target is not patched, then they do have a possibility of leveraging these attacks. So what we're looking at, though, is any operating system, Linux, Microsoft, IoT, which is sort of Linux, but it can be MS. So this is a little bit of both the above here, and mobile, which sort of is Linux in a way. But when it comes down to it, if it's remote, for all of these, for mobile, look at API calls. Again, now we're looking back at web vulnerabilities. So again, we have a huge overlap between, application attacks, operating system attacks, or web vulnerabilities, which is sort of application in a way. There's going to be this overlap. It's never always clear cut. We'll try to focus more on the operating system, but you got to think about your attack vector, and that's what we're talking about right here. Is it remote? Remote as in, of course, over the web, totally remote itself. Is it local? Local meaning you might need to be on on the network itself. So you might need to be in the actual network to actually access that host or operating system. And that could be from pivoting. And of course we have physical. You need to be right in front of it. Of course, physical access. So we need to consider those three factors when looking at our attack. So we'll see what they have to say here about that. And you can see here, we look at password cracking, which of course will probably either be local. It could be physical too. There are some attack tools you can use, like the Bash Bunny, Rubber Ducky. I don't have any link for that up here, but I don't have one. Never actually used one, but you can, if you get access to a physical port, you plug it in. If someone's logged in, they can try to execute specific attacks for you. And a lot of times it's going to be this, and I'll say as we go through the slide deck here. Sometimes if you have physical access or you get access itself, you try to maybe get local physical access to reach out remotely. What that means is maybe I plug in a USB, and the USB itself does not have the attack code. It has what you call a stage 1 deployer. So we have stage 1 on USB. It calls out over a common port, maybe 80.443. We know it's going to be open to a remote host that we have set up that has our exploit code. That code is downloaded and then executed with the privileges of that user. So that's a really common way to do it, and it can be from local also. You might use the local connection to have it reach out. So as you get in, actually you're on the LAN, you might find a way to download the code for you. And a part of this also is, for local, is social engineering. And this is where our web attack comes in. So the web itself 8443. Our web browser is really a key component here. Some of these attacks we're going to talk about, if I can get someone to click on a link, again, we're leveraging social engineering attack here. A link to be executed and have it go through the web browser. The user has already launched the web browser with certain permissions, and those permissions, the web browser itself might be able to leverage further attacks which give us more recon. It could be key logging, which we'll see here in a little bit. It could be opening a backdoor, remote access. So social engineering could be a huge part of that. And then part of that, of course, could be having someone click on a link that uses a common known open port to bring down some sort of code. And usually JavaScript is one, and that's example is the Beef attack framework. Now, modern browsers, a patch browser might block a lot of this. Endpoint protection, definitely if they have that running, could block this. So it is a very hard struggle. A lot of testing, you may do testing on your end, but still you might be able to get these attacks to kick off. So, of course, misconfigured services. This isn't really with the OS, but it's something you always have to consider. It's possible a misconfigured service will give you access to the host, and then allow you to actually maybe go further attacks. Again, what might be able to kick off that actual host exploit. So, tech in the host. I'll see up there. There you go. So again, attacks and flaws. Things to look at too is and this is some good stuff here. Is actually file and folder permissions. First off, just the fact that if you gain some sort of access, is it possible someone else may have put the wrong permissions on a file or folder? And this might lead more information. So again, we're always back to recon. And then reconnaissance, you should look for this. So it could be ways to look for that with a search command maybe built into the app itself. And understanding your operating system, so like C username. If you go up a level, can I go up a level and see other user folders? Can I get into those folders? Or if you're on Linux /home, maybe or maybe var www, can I break out above from that? Is it possible there's some permission issues there? Keyloggers. You can use remote keyloggers, hardware keyloggers. Yeah, that's possible. I mean, this is a physical attack vector here. So we're back to physical here. But software keyloggers is something easier to deploy, and that can be done via Beef, for example. Scheduled tasks. If they have something scheduled to run, you might be able to actually run something else, add scheduled tasks, replace components. It could be as possible as installing for Windows, for example, is to installing malicious control panel item, a CPL control panel item. So have that installed using the link to run32 DLL, the kickoff, and install a CPL file. And maybe that CPL file can be built with something like Venom. So something like that. You can use tools to build that sort of malicious CPL file. Default accounts. Again, we're looking at permissions here. We're looking for the misconfiguration of services. And I guess we may actually have kernel exploits, so we'll look at those in a second here. But when it comes to services themselves, close that. There we go. Oops, I don't want. So what we're looking for is, again, going back on OWASP. I know OWASP is a web app, attack framework, things to look at. But go deeper than that, because a lot of stuff, the web is going to be your major attack surface and attack vector. So, but security misconfiguration, again, it's possible the OS might have this. It's possible service might have it to get you further in. So, and vulnerable outdated components. So those two right there. And of course, identification, authentication failures, weak passwords. But security misconfiguration is a huge one. And it doesn't have to be just the operating system. Let's talk about an attack vector here that we didn't really talk about before, and that could be the cloud. Let's draw our little cloud here. The cloud access itself. So misconfigured cloud components. That should be added to your list of possible things. And it can be Linux, it can be Microsoft. It could be some combination of both. But anyways, something like an S3 bucket, the BOS misconfigured. Maybe it's leaking information out. So again, we're back to recon. I know I'm constantly harking on that again. You can see, if possible, the vulnerability. I need to go back to recon. I find that my target has a misconfigured S3 bucket, and in there's credentials I can use to attack and then go further exploit. So for the kernel itself, let's see that here. So kernel itself, there's some things to look at. We can look at it's called the sticky bit, GUID bits. These usually are not used too much, but again, never assume that they are. It's possible someone configured a service to run with a sticky bit, which means you can run it. It will run as root. So you might be able to leverage an attack, run it as a service that maybe it's not running right now, that has a sticky bit on it. That's what sticky bits are doing. Okay, sticky bits. Unsecure pseudo flags. It's give it a try. Try sudo something. Even if maybe you did get in as a Apache user, try doing a sudo netcat, whatever. See if you can get it to work. It should, and then you probably will have a logged. You'll create a log entry for that, but that's part of the attack process. So, Windows attack, LDAP, definitely a good one. Server, and this is really more of an app, but server messaging block, SMB is a huge one. But misconfigured policy groups, things like that. Active Directory scanning, definitely AD attacks. And of course, offline brute force attacks against passwords. If you can extract any credentials from that. So from Linux, again, sudo is one. Look for exploits and metasploit for the kernel version. Windows, if you can get the NTLM hashes, you can do that that offline attack. Registry, if you can get any registry information, like the SAM folder, things like that. Again, another one is DLL injection. You can create DLLs with malicious code. Again, those might be stopped by an endpoint protection, but this is definitely worth one of the options you can use in your attack route. So, all operating systems, look for file permission folders. Default passwords, default system passwords. Don't neglect that. That's a misconfiguration. It sort of falls in between misconfiguration and sort of security misconfiguration, authentication. I don't say authentication failure. It's more misconfiguration. So someone's using default passwords, and it doesn't mean. And that's what I have here. I'm sorry, someone. Other components here. I should add the ... Let's go and erase this down here. So when we're thinking of other components, printers, for example. So printers, a printer on the network, a network printer is always a good one, because they might have a default password. Our printers run almost like a web page where you can see the status. It could be out of date. It could be printers, VoIP components, voice over IP, telephone, telephony, switches, routers, things like that. So our network components, again, we'll just put ... I'm trying to write with my mouse. Don't discount those items. This should be part of your scan. You might find these are the items that might get you further into the network. So, but we'll talk about the actual one here. Again, writable services, sandbox escaping. If you might find yourself in a VM, it's possible to look for a VM escape. There are tools you can do to VM detection. A lot of times, just looking at the operating system or the hardware level, you might see some abstraction. Credential attacks, again, passwords. This really is this. So, Hashcat, John the Ripper, and we're going back to previous attack tools we talked about before. Dirbuster, WA3AF. Again, these are web application attacks. So, this is really more of a web app or a application attack vector, but again, they're so tightly coupled. Don't discount those. Let's look at that one thing here about looking at the version of the software you find. So in this case, let's say I find the version, it's Microsoft Windows Server 2019, and maybe I find by patch level they're running something in 2019 here. 2020, there's some overflow attacks. So I'll click on that, open a new tab. You can see here, maybe I go through these and find out they haven't patched this yet. And maybe I'm looking for remote attacks. So you can see here, It tells us the access here, right? Remote local network, low complexity. So maybe I want, like latest number 8, it has remote, low complexity, and there's no authentication required. So those things catch my attention, and it's a 10, which is probably the reason why this is that. So I click on this CVE, open it up here, and of course, if they had not been patched for this, definitely look at the Microsoft patch notes, and you can sort of just validate if it needs further scanning, OS scanning. Nmap's got some great OS scanning. Go deeper and see if you can find the version number, and possibly you might find some other, like research checkpoint. You might find if there's a Metasploit entry. And this is probably tiny. Here's my marker here. Keep using my marker. So Metasploit rated this CVE. Exploit DB, you can do CVE searches. But if there's a Metasploit module, you might be almost halfway there. And that's a really good thing. If not, though, don't give up. Because we can actually look at further, in this case, this PXE, this researchcheckpoint.com has an entry here about this vulnerability in Windows Server deployment services. So read through this stuff here, yada, 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 and you see how it happens. Fuzzing. Our first task when creating the TFTP dumb fuzzer using this tool. So we have an actual tool we can try. So there we go. Blue fuzz. So using this tool, point blue fuzz at this, you can see we're attacking this right here. Manually reverse server information of the WSDLL file. So I'm not going to go through all this in details, but you can see, though, you can find posted guidelines. And you can possibly try to go ahead and use this attack against your target. So don't discount searching through these. Now, they don't have one. It's going to be tough. Sometimes the patch notes will not, of course, usually give you advisory notes from Microsoft. Might not give you anything except mitigation, which, of course, is patch the system. But there's might not be links here to like how to actually do that. So just keep that in mind. One of the ones I use a lot is PacketStorm. You can search a PacketStorm under exploits, and sometimes you can find, here's a actual advisory proof of concept code. Again, you would need to go and understand some HTML coding. You would need to go ahead and figure out how to do this. Maybe use a curl attack, or I'm trying using Purposely Professional. So PackStorm's a good one under exploits. So yeah, Windows kernel registry virtualization and compatibility. Okay, yeah. See, in this case, nothing for that one. So back to recon. A lot of searching. Look over the post by the vendor. Apple, Microsoft, and so on, any Linux distro, but chances are they're not going to give you links to proof of concept code inside there. But look for other links in CVE. So like I mentioned, CVE details is fantastic. It's a way to go ahead and find the vector itself, local, remote, physical, complexity level, things like that. So it takes some research, but you can use CVE for this. Physical attack. Cold boot. This is a tough one. I mean, this is usually a stolen device, and you're crossing some borders here if you're stealing a device from your target. I'm trying to do cold boot attack in an offline system, but understand it is possible. It is there. This is a really tough attack vector. This is hardware level stuff. Pinning out the JTAG debugger. I have no experience with this. But don't discount it. It's a great research place. You can do security research here. I've seen talks about this, but it's possible to capture encryption keys, serial console, serial ports, other possible connections you can get to the system, and mobile. Again, don't forget mobile. Android is Linux. Even the Apple one is Linux. Now, I will hand to most mobile operating systems are really well sandboxed, but look for things like caching. Look for binary cache files and maybe run those through Linux strings and see if you can pull out any type of strings. Look for strings that are encoded, base 64, hexadecimal. Decode those, see what they are. Again, part of this process is trying something and it's not finding anything. Trying something and failing. Trying something not working. But you never know what you might do as you sift through these remnants of the output of an operating system. So take a look at the summary itself. Again, mobile devices, a little more different attack vectors. A good way to also this, and this is again leaning on, all right, stop, is set up a Wi-Fi access point on like a laptop or desktop. If the system like Mac, I know Mac and Linux, if I'm plugged into the network, I can turn the Wi-Fi into a hotspot, and then only connect that mobile device to the hotspot, and then I can run everything through Burp coming off that Wi-Fi port, Burp or Wireshark. And I can use those to look for insecure transmissions. I can use those to look for any calls out. Again, we're really looking at more of a network-based attack or app-based attack, but it's hard to say only OS. So what it comes down to is really when it comes to the core operating system, outside the password attacks and the applications that they're running, default passwords, look for open ports, SSH, Telnet, Telnet. Look for default passwords you can use there, default usernames. You can use password attacks against those ports. And of course, it's just looking for unpatched operating systems. So anyways, I think that really wraps up the summary of host exploits. Again, it's never really it's not as clear. Even the chapter itself talks about a lot of other attack vectors, but don't discount those. And a lot of times it's not as simple as just finding Windows that's not patched to a certain level and running an exploit against it. You might need to find other ways to get in and get that to run. So anyways, it's it for the chapter. Thank you for watching.